Hey everyone, I am Miss Hu, your physics teacher. In this video, we are going to be learning about gas pressure and atmospheric pressure. We will be specifically learning about the kinetic particle theory and how it relates to gas pressure, as well as the general concept of atmospheric pressure. Now, first things first, what is kinetic particle theory? To understand kinetic particle theory, let's first recall what we do know about the kinetic theory of matter. The term kinetic is related to movement. So the kinetic theory of matter states that all matter is made up of tiny, discrete particles which are in constant and random motion. This applies to everything that is matter, whether it's solid, liquid, or gas. So tiny, discrete means they're really small and they're all individual particles, all of which are in constant motion. So for example, for solids, they're still moving but on the spot. For example, they are vibrating. Liquids and gases are not only vibrating but they can also move, and they move in random directions. So this is generally what the kinetic theory of matter states. So now that we know about the kinetic theory of matter, let's go into the kinetic particle theory of gas. Actually, when it comes to kinetic particle theories, the kinetic particle theory does extend to solids and liquids as well. But in this lesson, we're going to focus on gases because we want to learn about how gas particles can exert pressure on a surface. That's why we'll be focusing only on the kinetic particle theory of gas. So, as you can see, the kinetic particle theory of gas is related to the kinetic theory of matter. The kinetic particle theory of gas states that gases consist of very small particles that are constantly moving in random directions. How do we use the kinetic particle theory of gas to explain how the gas particles are able to exert pressure? Because the gas particles are constantly moving, they will keep colliding and bouncing off surfaces and walls of containers. So using this, we can explain how gas particles exert pressure. So you should have learned about pressure in an earlier lesson. And if you'd like to know more, please watch my video about pressure. For now, we're just going to go through a really quick overview. And as you may recall, pressure is force per unit area. The formula here is P equals F over A. So if we're looking at pressure of solids, the force in this case is the weight of that solid. The area refers to the area in which that object is in contact with the surface. This object has several different surfaces on which we can rest on, say, a table. If you rest the object on its larger surface area, a larger area means that the force is more spread out, therefore it has lower pressure. However, if you place the object on a smaller area, the weight is concentrated on that smaller area, which means that the object will be exerting higher pressure on that small area. Now, if we look at liquid pressure, if you can recall, is measured using the formula P equals rho GH, where rho is the density of the liquid, G is the gravitational acceleration, and H is the depth at the point where we're measuring within the liquid. Now, liquid pressure does not depend on the volume of the liquid, the size of the container, and it's not like with the solids where we look at the area in which the liquid is acting. If you look at the formula, liquid pressure only depends on the density of the liquid, the gravitational acceleration, and the depth within the liquid, which is basically the formula. So these are the formula to calculate pressure for solids and liquids. Here's the thing, gases do not exert pressure the same way as solids and liquids. So why are we going through this? This is because when we look at pressure, we have to understand the difference between how solids, liquids, and gases exert pressure. So now let's get into gas pressure. We know that pressure is force per unit area, but how does this explain how gas particles are able to exert pressure on a surface? Now, depending on the syllabus that you are taking, there are slightly different ways of explaining this. Both are correct, it's just that one requires more in-depth explanation compared to the other. We'll start off first with the explanation for IGCSE. So in IGCSE Physics, they normally require you to explain how gas particles can exert a pressure and relate it to momentum, because momentum is product of mass and velocity. So that means that we want to understand how the particles, because they are moving, therefore having momentum, are able to exert pressure. So because we know due to the constant motion of the gas particles, they will be colliding off the walls of the container. So the collision between the gas particles with the walls of the container produces a change in momentum. This is how we can relate the collision with momentum. The rate of change of momentum is the force between the gas particles and the walls of the container. This is something you should have learned in momentum and forces. If you don't remember anything about this, please watch my video on momentum, impulse, and impulsive force. So basically, the rate of change of momentum is the force. And from this force, we'll find that gas can exert a pressure because gas pressure is the average force per unit surface area of the container. So I'm going to list out the formula here for you to be able to see the relationship from the change in momentum to the force to the pressure. So the change of momentum is actually impulse. So force is the rate of change of momentum. The term rate here meaning divided by time. Therefore, force is change of momentum divided by time, or you can say impulse divided by time. Gas pressure is the average force per unit area, so force divided by area. If you can understand this flow, it would really help you in enabling you to explain how gas particles are able to exert pressure. One thing to point out to you, always talk about the collision between the gas particles and the walls of the container, or the collision between the gas particles and the surface it's exerting pressure on. Many students tend to talk about collision between the gas particles with each other, but that is not what is exerting pressure. That's just exerting pressure to each other. Remember that when we talk about gas pressure, when we measure gas pressure, we're measuring how the gas particles are exerting the pressure with the measuring device. So when we talk about measuring gas pressure, it is about measuring the pressure which the gas particles are exerting on the measuring device. That means the surface of the device which is measuring that gas pressure. So that's why we don't talk about the collision between the gas particles with each other. It is the collision between the gas particles with the surface it's exerting pressure on. That applies also when you want to explain this in SPM. So in this case, how to explain the gas particles are able to exert pressure on a surface? This is once again related to the formula of pressure being equal to force per unit area. So to explain how the gas particles can exert pressure, you need to explain that the collision between the gas particles with the walls of the container produces an impulsive force. Remember that impulsive force is the force that's exerted due to the collision between the two objects. Gas pressure is the average impulsive force per unit surface area of the container. As you can see, this is related to the pressure formula. Going to repeat the explanation of the collision for the benefit of students who have skipped the previous slide straight to this slide. Remember, when you talk about a collision, you have to state that the collision is between the gas particles with the walls of the container. Many students write about the collision between the gas particles with each other. That's not what is exerting gas pressure. They're exerting pressure to themselves. But when you want to measure gas pressure, you need to measure the gas pressure that is being acted upon by the particles onto the measuring device, which means that you need to talk about the collision between the gas particles with the surface from which we are measuring where the pressure is acting. That's why you talk about the collision between gas particles with the walls or the surface of the container, not the collision between the gas particles with themselves. By the way, if you are comparing the explanations between IGCSE and SPM, they're actually pretty much the same thing. It's just that IGCSE focuses more about momentum, whereas SPM goes straight to the point by discussing how the force is related to pressure. Now, remember that gas pressure is due to the collision of gas particles with the walls of the container, not due to the collisions between gas particles. And this is because when we measure gas pressure, we're actually measuring the pressure based on the collision of the gas particles with the walls of the measuring device. What are the measuring instruments that can be used to measure gas pressure? We typically use a device known as a Bourdon gauge are also known as the pressure gauge. Another device that can be used is the manometer, also known as a U-tube. It's called a U-tube because it's shaped like a U. The device that's more commonly used is the Bourdon gauge or pressure gauge because it's very easy to use. All we need to do is hook up the gauge to the container which contains the gas, and the value can be read immediately from the scale on the gauge. However, because it's so easy to read, there are not that many questions on the gauge. So more exam questions are asked based on the manometer or the U-tube because learning to read this can be a little bit tricky, which is why exam questions are based more on this device. In this video, I'm not going to go through how to take measurements or solve questions with the manometer, so please watch my video where I explain how manometers work and how to solve questions. In the meantime, let's move on with atmospheric pressure. First of all, what's the difference? So when we use the term gas pressure, we are typically referring to the pressure of the gas trapped in a container. For example, gas in a tank, or in a car tire, or in a spray can. Atmospheric pressure, on the other hand, refers to the pressure caused by the air in the atmosphere around us. What causes atmospheric pressure? Atmospheric pressure is the force exerted on the surface by the air above it as gravity pulls it to Earth. As you should know by now, we have layers of air on Earth which make up the atmosphere, and atmospheric pressure is quite simply the pressure exerted by the air in these layers of the atmosphere. So unlike gas pressure, atmospheric pressure is not trapped in any container. And therefore, to measure atmospheric pressure, we would be using devices that are different from those that we use to measure gas pressure. The measuring instrument used to measure atmospheric pressure is known as barometer. There are a few types of barometers. We'll go through two general types for now, which are the aneroid barometer as well as the 14 barometer, also known as the mercury barometer. In daily life, the aneroid barometer is more commonly used. Similar to the gauge, you can see that there's a scale there. So all we need to do is just take the value of the atmospheric pressure directly from the scale on the aneroid barometer. There is no need to hook up this barometer to anything or to try to figure out how to read it. All we need to do is just take a look, and there the value is. However, because it's so simple to use, again, not many exam questions are based on this device, even though it's the more commonly used device. So more exam questions are asked based on the mercury barometer or 14 barometer. Again, because it's a little bit more complex and we need to understand what readings we are looking at and how to calculate or read the value from the scale on the mercury barometer. In this video, I'm not going to go through the barometers right now as well. I'll be covering that in another video, so please watch that video on how barometers work and how to solve exam questions. Other things you need to know about the atmospheric pressure. Atmospheric pressure depends on the altitude. The higher the altitude, the lower the atmospheric pressure. This should make sense because the higher we go in terms of altitude, the less air there is pressing down on that point because there's less layers of atmosphere acting at that point. That's why the higher we climb a mountain, the less air we seem to be breathing in because there's less air particles in the same volume at that point, therefore lower atmospheric pressure. Generally, the atmospheric pressure at sea level is taken to be the same. So remember that just because we say that we are at sea level doesn't mean that you have to be right next to the sea. It just means that we are at the same level as the surface of the sea. So we could be on land in the middle of a peninsula or island or even a giant continent, as long as the level of that land is equal to the surface of the sea, that's said to be sea level. So because the atmospheric pressure at the sea level is taken to be the same, the measurements have already been taken all over the world. There may be some differing values because we're not all exactly at the same level, but we kind of round up because it makes it easier for calculations and for comparisons. Now, you do need to roughly know the values of atmospheric pressure at sea level. There are several ways in which we can express the values because, we like to use many different units, right? So the value in Pascal, which is the SI unit for pressure, is 100 kilopascals, or you can also write it as 100,000 pascals. It is also sometimes expressed as 1 atm, where atm in this case is the unit for atmospheric pressure. So 1 atm refers to the value of the atmospheric pressure at sea level. If you see a value of 2 atm, that means the pressure at that point is double the value of the atmospheric pressure at sea level. Atmospheric pressure can also be expressed using the unit of bar. So 1 bar is also the value of the atmospheric pressure at sea level. And in fact, this is where the term barometer comes from. So bar is actually an older unit, and ATM is a unit that came up much later. Until today, though, we are still using the unit bar. Atmospheric pressure can also be expressed with the values of 76 cm/Hg or 760 mm/Hg, where Hg is the chemical symbol for mercury, which means 76 centimeters of mercury or 760 millimeters of mercury. If you're wondering what an unusual set of numbers and where do these come from, this is actually taken from the mercury barometer. So to understand this better, please watch my video about barometers. Now, if you want to express atmospheric pressure with this mercury measurement, you must have the value of the length. So that's why it's cm/Hg or mm/Hg. If you only measure length, like 76 cm, that's not pressure, that's just length. You also cannot just say 76 Hg because that makes no sense. What, 76 mercury? So 76 cm mercury means that atmospheric pressure is equal to the pressure applied by 76 centimeters of mercury, or in mm, 760 millimeters of mercury. Now, another way to express the atmospheric pressure, instead of using mercury, we can also use water if we were to be using a water barometer. In this case, if you use a water barometer, you would find that the height of the water is 10 meters. That's why we have to write it as 10 meters H2O, which is actually water. This means that the atmospheric pressure at sea level is equivalent to the pressure exerted by 10 meters of water. Again, if you'd like to understand this in further detail, please watch my video on barometers. For now, that's the end of the lesson. So if you found this lesson to be educational and helpful, please click like and subscribe for more lessons, solutions, and exam strategies from your physics teacher, Ms. Ho. If you would like an updated list of lessons and videos from me, you can also check out my website at physicsrocks.com. Happy studying!